Welcome to Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. This week, we explore Mother Nature. In the second half of our show, we'll speak with Warren Meyer, founder and president of Recreation Resource Management, about his efforts to more soundly manage public parks. Up first, we're pleased to welcome atmospheric physicist and MIT professor emeritus Dick Lindzen. Dick was lead author on the Physical Climate Process section of the UN's Intergovernmental Panel on Climate Change's third assessment report. Dick, welcome to the show.
My pleasure.
Dick, I ask you on because few scientific subjects have engendered as much political animosity as the debate about anthropogenic global warming, otherwise called climate change. I prefer not to jump right into the controversy, but rather have you take us through some of the basics of how climate measurements are made, how climate models are built, how those models are tested, and what predictive power the IPCC consensus models have actually demonstrated. Let's start with what should be a simple concept, temperature. How do scientists measure the temperature of all of planet Earth? And when they declare this to be the hottest year on record, what does that actually mean?
It's not an easy question, Bill. If you think about it a little bit, you have thermometers all over the world. Some are on mountaintops, some are in valleys, some are in cities, some are in the forest. If you average all of them...
What does that mean?
I don't know. Nobody knows what it means. You have no comparable basis. So they don't do that. What they do is hope that there's some meaning to the temperature change at each station. So, for instance, you have a station any place. You might take a 30-year average, I forget what period, 1950 to 1980 or something. And you ask, how different from that average is the temperature at that station? And then you average those differences. And that assumes that, you have a stable platform. You have the same thermometer. It assumes that the city or location has not changed. It hasn't cooled or warmed or whatever.
So what kind of errors besides that can be introduced into these records?
They change instruments. A few years ago, they went over from traditional thermometers to electronic thermometers. Those have different properties. They're supposed to take it at fixed times during the day, but shifts, or how many times a day they record it, will influence things. If you want a daily measurement, do you take 6 p.m. minus 6 a.m. or 12 versus 12 or so on? That all makes a difference. It doesn't make a big difference for the purpose for which these measurements were made, which was not climate.
Interesting.
It was for weather forecasting. And if you look at a weather forecast, you don't care if it changed 0.2 of a degree. You couldn't measure that. You couldn't feel that. You want to know, did it go up 10 degrees, 20 degrees? Is a cold front coming through? So for those purposes, for weather forecasts and so on, for people's lives, these measurements were adequate.
And we see these reports when various agencies like the National Oceanographic and Atmospheric Administration report on the temperature measurements they've collected. Do they report the raw data or do they make adjustments before they publish?
By definition, if they're reporting on global mean temperature anomaly, which is what they use, of course it involves adjustments. You have to process this. You have to take the average. You have to move from it. They also do have adjustments. We know that urban areas introduce warmth, and they have formulas that they designed to, quote, correct for it. And again, the problem is not that this is illegitimate, but that if you're worried about 0.1 of a degree, it's totally inadequate.
Because the fundamental error in the measurement is larger.
Yeah. The fact of the matter that you have adjustments of a few 0.1 of a degree means they weren't good to that.
When were satellite atmospheric temperature measurements introduced, and how did they change the science?
Satellites began in 1978. Now, you have to remember, they're not measuring surface temperature. Neither are the thermometers, by the way. They are not at the surface. There's an international agreement. They're supposed to be, 3 meters above the ground or something like that. The satellites are measuring thick layers of the atmosphere. The other way we measure that is with balloons. The balloons go back to the mid-60s as a reliable means of measurement at, order 500 stations around the Earth. They send up balloons twice a day, same universal time.
Mm-hmm.
They take the measurements, they have thermistors in them. The balloon goes up, drops a package, the altimetry is measured, and the temperatures are recorded according to pressure level. What the satellites do is they look at radiation, microwave radiation, infrared, in some cases, and they infer from that a distribution of temperature. This is only very coarse measurements in the vertical. So you have average temperatures for a layer several kilometers deep near the ground, something higher up, and so on. The one near the ground, few kilometers thick, is representing what the models say is the region you should see most of the warming. So it's a reasonable thing to keep track of. The virtue of the satellites is, of course, they have global coverage. The thermometers have very poor coverage over the oceans, and that's 70% of the Earth. They are not measuring exactly the same thing. They are more consistent over time, but even there are many things to correct for, the orbital decay, other things. And so they also have their own corrections. They are more nearly, I would say, corrections than adjustments, but, that's semantics to some extent.
So, Dick, how are all these collected measurements used to build climate models, and what are these models?
They're not used to build the models. I mean, that's the first thing. The models that you have are, in many respects, no different than the models used for weather forecasting. What they do is they start out with the mathematical equations for the motion of a gas, air, for the mixture of gases sometimes if they're more sophisticated. They try and keep track of moisture, change of phase as it changes between vapor and water and ice.
A lot of parameters.
A lot of things going on. They're nonlinear, which means they're complicated to solve. They're hard to solve. They have the equations for radiation, the greenhouse effect, all that stuff. You can go on and on. Some of the more sophisticated ones have dust and aerosols and stuff like that.
Well, as an engineer, we build models all the time, and the proof of the pudding is, can it make accurate predictions?
Yeah.
How are these models tested?
Well, there are two kinds of models. Let's take an economics model. The usual joke is, God created economists to make weathermen look good.
Yeah.
But be that as it may, the economics models are not based on a known set of equations. We don't have the physics of the economy. We do nominally have the physics of the motion of the air.
So shouldn't they be more accurate?
Only if you can solve them with a computer model that can approximate things on a fine enough mesh. That mesh may have to be as fine as a centimeter.
And how far apart are these measurement stations?
The measurement stations are much further apart. In the northern hemisphere, they may be tens to hundreds of kilometers. Over the ocean, thousands of kilometers. Over Africa and places like that, they may be hundreds to thousands.
So the fundamental granularity of the measurement mesh doesn't fit the need of...
Oh, no, not at all. But in addition, the computer model, the resolution of even a very good model on a supercomputer is 10 kilometers, when you might need 10 centimeters. So you don't even know if you're getting the solution to the equation.
Be that as it may, how good a job have these models done in at least being able to look at the past and accurately represent what's gone on?
It's a tricky issue. How do you test that? You see, the existing models, for instance, if you restrict yourself to this global mean temperature anomaly, one variable, the others may be way off, but let's take that one. If they predict too much increase in temperature, they have thus far added aerosols and said those cancel it. So they adjust it to look like the period they know. It's a little like taking an exam and being told the answer in advance.
So you can goal seek the model to
Yes,
fit whatever you want.
But the bigger test is run models forward.
Mm-hmm.
And if you do that, virtually every model used by the UN from 1978 to the present is overestimating the observed change in temperature.
Has any IPCC model ever successfully and accurately predicted the future?
No.
As the IPCC has produced new and newer models over the last 25 years, have they increased in accuracy?
It depends on who you ask. How shall I put it? With respect to the grossest measure, what is called climate sensitivity, this is by convention, how much warming do you expect for a doubling of carbon dioxide?
Okay.
Doubling is chosen for a very good reason. The dependence of the greenhouse effect on carbon dioxide is what is called logarithmic.
Right.
Which means if you double from 280 to 560, you'll get the same thing as you'd get from doubling from 560 to 10120.
Mm-hmm.
It's a diminishing return thing. In 1979, there was a report, and based on the models of that time, it said the range seems to be from 1.5 to 4.5 for the models.
That's a pretty big range.
Yeah, and it's not necessarily correct, because that's just what the models are producing.
Mm.
And in the latest IPCC, the range is 1.5 to 4.5.
So nothing's changed in all those years?
Not with the, well, actually it has. They tried in the previous IPCC report, I think the third assessment, to bring the bottom up to 2 and say that the most likely was 3. In the latest report, they brought the bottom back down to 1.5 and said they have no basis for saying which is the most likely.
There seems to be some controversy over whether there's been a pause in global warming over the last 18 years. You can see reports from both sides of that argument that seem to bear no relation to each other. What's your view on that?
Look, you look at the temperature records for the ground, from the satellites, for anything, and what you see is something flopping around a few tenths of a degree, but no obvious trend for at least 18 years. Now, people are then saying, well, if I take 2015 and it's a tenth or two higher than 98 or something like that, now I can draw a trend line through this that makes it look like it went up a tenth or two of a degree.
Mm.
The problem with that is, if something is flopping around with a zero mean, and you pick your endpoint selectively,
right,
you can get it go up, get it go down. It's a distraction.
But the runaway warming that had been predicted by earlier models doesn't seem to be happening.
Oh, not at all. They're all going much higher than
reality.
No matter how you adjusted the temperature. It isn't a question, did it go up or did it go down? The question is always how much.
So did 97% of scientists really agree that catastrophic global warming is inevitable if we don't radically reduce global carbon dioxide emissions?
Of course not.
But that seems to be the narrative.
I know. And it was the narrative from the beginning. In 1988, when there was the Senate hearing where Jim Hansen made some vague remarks, Newsweek ran a cover saying all scientists agree. Now, they never really tell you exactly what they agreed on. So all scientists agree that it's probably warmer now than it was at the end of the Little Ice Age.
Mm-hmm.
Almost all scientists agree that adding CO2 should give you some warming, though it might be very little. But it is propagandists who translate that into it is dangerous, we must reduce CO2, etc. That doesn't even come from the IPCC scientific assessment.
Although the scientists don't seem to be speaking out against it.
No, they don't.
How do you explain that?
You could be cynical and say when the funding goes up by a factor of 10 or 20, that has an influence.
Mm. How do you account for the vicious personal attacks being made against scientists who publicly question this global warming consensus?
It's an interesting question. I'm not sure of the answer. I think Bernie Sanders, heard on TV, wants to criminalize questioning it.
Right.
This is getting a little bit crazy. What's interesting is, first of all, it's usually not scientists who are hurling these. You have people like Rahm and so on who start fulminating at anyone who questions it. But within the science community, the real division is much more subtle. So I would say IPCC Working Group 1, which is the scientific assessment, the general position they adopt is that there is warming. It is mostly due to man in recent years, meaning since about 1960, 1970, not before, and it is potentially dangerous. Okay. And the skeptical position is there are many causes of the change, and it doesn't look like the sensitivity is enough for it to be serious. So, this is a discussable issue. Neither side is saying catastrophe is around the corner.
But yet that seems to be the cry of politicians
and environmentalists and all these people who have been pushing this issue, sure. And the scientists, to a large measure, go along with it. They'll always admit, Ralph Cicerone has said this, he's president of the National Academy, that they don't know the sensitivity, which is the crucial parameter. They're really saying they don't know there's a problem.
So they can't say there isn't a problem.
Yeah.
So therefore, let's go along, especially if the funding is big enough.
Exactly. If you can make an ambiguous remark, and you have people who will amplify it, they said it, not me, and the response of the political system is to increase your funding, what's not to like?
You spent many years at MIT as a professor, and you've certainly seen this play out there. What range of opinions have you observed on the MIT faculty?
First thing I would point out is I checked a few years ago as to seminars on global warming. The vast bulk of the seminars on global warming were not in the department dealing with the science. They were in political science. They were even in literature, civil engineering, and so on, nuclear.
So a lot of people have jumped on this bandwagon.
Oh, sure. And for the policy types, you want it to be policy. You have the Sloan School involved, the business school. They're all discussing it and seeing, whether their favorite program could fit in.
Narrow us down just to the folks that you've worked with who are actual climate scientists, or at least physicists who are doing climate science.
Absolutely.
What do they think?
I would say if I look through my department, at least half of them keep mum.
Wow. Heads down.
Yeah. Just keep on doing your work, trying to figure out how it works. There is a tendency for the Institute to publicize anything that may be relevant to this. And I think there is a reluctance to say that this may not be important.
Well, it would affect other programs, their energy programs, their solar programs.
The Institute just has announced that they see this bringing in $300 million. It'll support all sorts of things.
Yeah, what's not to like?
Yeah, exactly.
Dick, as you see young scientists coming up in the field, do they find themselves very energized by this topic?
It's an interesting question. We're getting applications from a different group. When I started teaching, there was a real split in graduate school. You had undergraduates studying meteorology with the intention of becoming weathermen. The graduate students in fields like meteorology came from physics and math. Because these are hard problems in physics and math.
Interesting, yeah.
Physics and math no longer have an overflow. As student interest shifted to, law, business, so on. We increasingly are getting students who are not as sophisticated as they used to be. The other thing about it is, for young scientists, they know it'll kill their career to take a position on this.
Buck the party line?
Yeah, it would be murderous. They couldn't publish, they couldn't get funding. Funding has become crucial to promotion. And I think what a lot of them do is just try and stay away from the topic.
What does this say about the whole peer-reviewed science community and the financing of it, particularly from government?
Government has a monopoly. Science in this country is funded by the government, and that has its implication. Dwight Eisenhower picked this up already many years ago when he said, that one of the dangers of this is a government contract might be a replacement for scientific results. And indeed, when you get letters asking for letters of recommendation for promotions and things like that, very often the question is, what kind of fundraising can we expect from this person? So these are by no means minor considerations, and young people know that they have to bring in funds. This becomes even more important at modern universities, where the area of major growth has been administration.
Sure.
And administration depends on the overhead on grants.
Yeah.
No, it's a tough situation, and I know even with my own students, if we did research that was relevant, we often tried to downplay the implication. Just keep it to the bare bones. Don't make any implications that might rock the boat, because, they have their own careers to worry about.
Dick, you're emeritus now. You're wrapping up a very successful career. What advice do you have for those of us in the general public that are trying to make sense out of this global warming debate?
Well, you're starting out with a select group, namely a group that wants to make sense out of this issue.
Okay.
And if you have such a group, and I think there are some people like that, there are things they can dig into. You'd have to suspend your desire to get one result or the other and try and learn how it works and why there are questions.
Isn't that called the scientific method?
Oh, yeah. Partly, anyway.
Dick, it's been a pleasure. Thanks so much for being on the show.
Thank you.
That was Professor Dick Lindzen from MIT, here on Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. You can check out Real Clear Radio on Facebook or follow us on Twitter at Real Clear Frezza. While you're at it, take a look at realclearmarkets.com, my go-to place for diverse views on political economics. Today's program was partially underwritten by the generous support of Old Boston Restorations, a Victorian property management company in Boston's South End. Ahead, we'll speak with Warren Meyer, founder and president of Recreation Resource Management, about saving our national parks through public-private partnerships. Stay tuned.